Welcome everybody to Sustainable River Basin Management Module 3.2, Part 2. This time I'm going to speak to you about monitoring. Now, monitoring is a tool, and that tool serves planning and it also serves enforcement. Those are the major objectives of monitoring. And what we want to achieve is the enforcement. Monitoring is compliance checks. We want to conduct direct monitoring, indirect monitoring, indicative monitoring, but in many cases we combine one or two or more of these major objectives in one exercise of monitoring. Now, the purpose of the monitoring is to develop a reliable knowledge base of water resources availability as a basis for management. So first of all, we need to have our background data. We need to monitor what is going on over a range of time, a range of space, to be able to come to our water budgets, which serve as a basis for water allocation, for water management. And then we have to ensure that water allocation systems are effective and permits are being complied with. So there are two major objectives, clearly one building on the other, but one already going into allocation and into financial sustainability and economic sustainability of water. And the third one is to ensure pollution control and that we have a system in place that is effective, and again that there are permits attached to the pollution control monitoring which are complied with. So those are the components. The monitoring systems are often divided into or distinguished into three levels. First of all, the national level networks, which in most of the cases, in most of the countries, are subdivided by sectors. All of those run their own national level networks. For instance, the meteorological services, the agricultural departments or ministries, transport and navigation, the airports, for instance, run their own systems, disaster management, and there may be many more running their own networks. Then we have basin level networks, which cover certain parts of river basins or entire river basins, watersheds, or just command areas under agricultural usage, the irrigation perspective of the system, or hydropower management perspective of water sheds. And then we may have as the lowest level of these monitoring systems, individual or research-driven monitoring networks, or even private networks, for instance in the case of forestry plantations or large farming corporations running their own monitoring systems. And then we have one outside, standing outside the state boundaries, and those are global satellite-based networks which increasingly become important. Now we can classify monitoring into the primary gauging stations. The purpose of these primary gauging stations is to give reliable long-term measures, and this requires what is expected from these primary gauging stations is accurate and consistent data over a long-term range. So this also means that primary gauging stations are supposed to have a fixed location or not move because of larger infrastructure projects, for instance. Those are spaces which are reserved and fixed so as to allow long-term records to be collected from under one and the same landscape condition. very often this is not simple, because in many cases this is simply not seen as very important that a primary gauging station is being maintained when some other interests in terms of land development are at stake. And then we have secondary gauging stations. Those are seen to support primary stations. They focus more on compliance monitoring. With those secondary gauging stations, we primarily want to achieve a change detection. So when we look at compliance, we can more easily detect violation of compliance by detecting changes in certain parameters. And then there are tertiary gauging stations which provide or are considered to be a temporary setup and serve specific studies only. Now let's look into the monitoring reliability. It can't be understated or not stated often enough that it's better to have only a few stations, however, stations that give reliable results, than aiming at many stations and obtaining uncertain results. So if efforts are made and only resources are very limited, it's better to put those efforts into fewer stations rather than forcing a collection or putting many resources into the station setup installations and then not being able to run and collect data at a regular and qualitatively good standard. Now, some data can be retrieved from archived repositories even after many years, and that is quite important also in making the decision of how many stations and where, in which part to invest when we want to obtain reliable long-term monitoring data. We can obtain records from archives, from satellite imagery, which can give us information on flood events, for instance, on water quantities. We can obtain, even after many years, information or data from about groundwater abstraction. What can often not be recovered is water quality data, and that's why I want to underline the importance of water quality monitoring in the first place. Now let's look into the surface water resources and stations. The primary stations, and that is all recommendation in a perfect world, should have an even coverage over the entire river basin. It should also target natural flow conditions, and it should enable accurate and consistent measurements. It should be easily accessible at any time throughout the year. There should be a limited number, and if possible should not be more than 10 stations, and very optimal would be automated recording and data storage facilities, which would relieve the human factor, or the risk with human factors from the readings. Let's just reflect upon this. This is a typical discharge curve. We have time here, we have discharge, and the amounts of discharge taking place over time. And the difference between an automated station and human or manual reading, where one person is going to a specific predetermined times and collects the data records and fills in some forms, is exactly this, that we may only be able to capture part of a discharge event, whereas the real discharge may have occurred during a time when no recording is taking place. So this is one of the reasons why these automated recordings are so important and that data storage is so important. Now let's continue on these surface water resources stations, and besides the scientific reasons of setting up primary stations, there are additional points to that which have to do with the manpower and the resources that should go into this. There should be a budget for maintenance, so those stations need to be well maintained. There must be a budget available to pay the observers, those on which we rely for the data recording. Those observers for primary stations need to be educated. They must be able to understand what they are doing, to report in time, to be able to write and monitor changes also, and inform about changes. And there must be funding available for data logging equipment, and there should be a preferentially remote data transfer available, so that under extreme events, information or data can be made available at the data decision-making points, which may be quite far away from the station. Now, this is on the primary stations. Let's look into the secondary stations and the conditions. They should cover mostly upstream abstractions. They should target the major users. They may be operated only during parts of the year when major abstractions are taking place, for instance, for irrigation or for mining. And the resources can be allocated as they are available, or as the need is coming up for these compliance monitoring programs. Now, having talked about surface water resources, let's quickly touch upon groundwater resources monitoring. And there are two major purposes for that. First of all, to assess availability. Is there groundwater? In which quality and quantity is that water available? And to assess changes. Those are the major points for which primary and secondary monitoring points are set up for groundwater. And the rest applies, as said, for the surface water stations. Then there's a component which is important, which is about water abstraction. So when we talk about water allocation, we also need to be able to monitor how much of water has been abstracted, to make sure that what has been allocated is indeed the amount that is being abstracted and used. And for that, the monitoring data is derived from the pump capacity and the time of operation of the pumps. It could also be derived from the areas under irrigation, and it could also be derived from the fees which are generated from selling water at a water utility. So those are indirect measurements of water abstraction which help us monitor compliance. And then there are three forms of funding this. One is through the allocation fees, which could be regulated. It could be through the self-monitoring, means that a stakeholder, a farmer, or a major water utility is monitoring its own water abstraction and reporting back about it and paying accordingly, or the control or compliance done by an agency or a water authority or some contracted auditor from the outside. All of this requires control measurements, even if the self-monitoring is working well, even if the authorities are doing good monitoring, it requires control measurements which should be independent from the three of those. Now, Let's move into the water quality aspects. First of all, we measure water quality in rivers, in primary stations or primary networks. And what we measure there is load of a certain element or certain chemicals, of certain of sediments and so on. So that is what we want to obtain from a primary network. From a secondary network, we will only be collecting concentrations, and those are relative changes. This gives us only information on relative changes because, as you can imagine, concentrations will likely increase at low flows and dilute or be low at high flows in a river. So this will not tell us exactly what is going on in terms of water quality, and both of those will give us different details of information in terms of water utilization or possibilities to use the water on a downstream end and monitor what is going on in the upstream part. And then we have point source water quality monitoring. That could be a self-monitoring and a reporting scheme of a company, for instance, farmers or individuals that would be on the compliance. And there would be spot checks that in a very infrequent way somebody would come and conduct measurements and check if everything is within range or not. And those spot checks would usually take place during times when operations are maybe not going on, or certain operations are operating or are working. For instance, the application of fertilizers during a certain period of the year, or the application of pesticides during certain growth periods, or during nighttime when actually nobody should be working in a factory, for instance, and exactly during those times the major discharges of effluents take place. So that is when those spot checks should be run to monitor and detect what's going on outside the view. So this means that on water quality we still have to differentiate between a continuous measurement and a point measurement. Even at these primary stations, there will be usually not a continuous measurement. Sometimes this exists. And there should be a priority to some key parameters which are indicative to a certain region. If there's a certain industry in place, you would monitor maybe for certain parameters that you expect associated with that industry to monitor what is going on in terms of water quality. So it doesn't make sense to monitor everything possible or anything that a local laboratory is capable of monitoring, but to put the resources specifically into monitoring what is relevant to the specific river basin or river system. Important on water quality monitoring is also the sampling procedure as such, which is determined by the type of parameter we are analyzing, the level up to which we want to analyze the information. Do we want to get it as a qualitative or a quantitative measurement? It's determined by the laboratory's needs. And then there must be a quality control component to the laboratory analysis themselves. So it should be a registered or authorized laboratory that conducts these water quality monitoring analysis so that they become legal documents. The laboratory report about water quality monitoring should have the level of a legally accepted document. So this is extremely important and very often forgotten because already at the sampling the sampling procedure fails by just picking an empty wine bottle and put a water sample into that or something else, and then the transport fails from the sampling site to the laboratory, and so on. There are so many things that can go wrong already at the sample point, which make the entire quality monitoring a nonsense operation. Now, and then there are parameters which have to be measured in situ. There's no need or no meaning in measuring EC or pH somewhere in a laboratory later. When it has been measured in laboratories as part of the sampling preparation to feed this into a certain analytical equipment for measurement, but to know about the water quality in situ of that specific river or that specific groundwater, those parameters have to be measured immediately as part of the sampling. And those parameters are indicative parameters which give us an idea about the water quality and whether there is an issue that would require further attention. So if additional sampling, additional laboratory analysis are actually required, that is something that we can in parts already estimate from our in situ parameters. Now, important to water quality monitoring also is the frequency of monitoring. Should we only monitor twice a year, just before the rainy season or just at peak dry season? Should we monitor every month or every second week? What should be the frequency of this? And this depends on our budget, and it depends on the objectives of the monitoring. And we should be able to assure comparability of the results. And this has to do first of all with the sampling in itself, but it also has to do with the laboratory, how well quality control standards are in that specific laboratory. And we have to assure data quality, which comes down to how we record our data in databases or in data and information management systems, so that this information is not being lost or transformed into useless information just because not all digits can be maintained in the database, or some errors occur between transforming the same information from one unit into another unit, and so on. Now, the monitoring data use makes only sense to monitor data and manage the monitoring stations if those data that we collect from these monitoring systems are actually used and managed properly. So that also means that it's not only capturing that data, putting it into a system somewhere, it must be transformed into information, and it also must reach back to the stakeholders. And there must be a mechanism to disseminate that information. Remember that what we measure in this very moment is being outdated or the moment we get our results from the laboratory. So it's past information, and as time moves on, that information becomes even less useful in many cases in terms of water quality. So it's important to only monitor if that information comes into use, into practical decision taking. Now, a suggestion to take home for you and think about, where would you place gauging stations in a transboundary river basin? Think about this. How would you monitor rivers which have a very huge discharge? How would you monitor rivers with large interannual variations? Let's say the river falls dry during some months of the year, and then it may have a very large discharge again, or there may be a situation where the river may have a reverse flow depending in a floodplain scenario, for instance, and the next months it will have again the ordinary direction of flow. How would you monitor such rivers, and where would you allocate your funds for monitoring under budget constraints? And with these questions or suggestions, I would leave you now, and I see you next time again.